Okay, now let's go into a little more detail on the specifics of the components of the motor. We'll start with a rotor and a stator. And what we need to do is let's take that motor we were looking at earlier and let's do an expanded view of that. And let's look in the inside here and see what's going on. So here's our exploded view of that cage motor that we were just looking at. And now we can see all these components a lot better. The rotor is the first thing we'll talk about. The rotor is this part of the motor, and it's separated from the stator, which is this part. Of course, so this resides in there when it's in operation. And so the rotor separated from this by the stator by this the smallest of margins. It really depends on the power of the motor, but he says from 0.4 millimeters, to 4 millimeters, depending on the size. He also says that the stator, it is a steel frame and it supports a hollow cylindrical core, and it's comprised of stacked laminations. Again, we like the stacked laminations so that we can eliminate the eddy currents that occur when ferromagnetic materials exposed to a magnetic field. So it's they're stacked and insulated from each other laminations, and a number of evenly spaced slots are punched out of the internal circumference of the lamination to provide the space for the stator winding. The rotor is composed of also punched laminations, and they're stacked to create this series of rotor slots to provide space for the rotor windings. Now, there are two types of rotor windings. There's this conventional three-phase winding of insulated wire, and the other is a squirrel cage winding. We're going to kind of focus on squirrel cage windings in what time we have left in this course. The two types of windings give the names of wound rotor, and squirrel cage, okay? So those are the designations of the two types of rotors. And, specifically to the squirrel cage rotor, it's composed of bare copper bars, and they're slightly longer than the, see if I can blow this up a little bit. That's about as good as I can do. But anyway, it's composed of bare copper bars, and they're slightly longer than the rotor itself, and the ends are welded together to two copper end rings so that everything is short-circuited. So the entire construction resembles a squirrel cage, actually, and that's where the name comes from. So, in small and medium-sized motors, the bars and end rings are made of aluminum, and they're molded to form this block. And so if we go to the next slide here, this is a die-cast aluminum squirrel cage rotor. This would be this fan that is a part of this. This part has nothing to do with the electrical mechanical operation of it. It is really just there to provide airflow over this machine, okay? And then as we look at some others, that's 13A, and this is showing the steps in manufacturing a stator and a rotor. And you start with sheet steel, then you blank it out, you punch it, you provide the spaces for the conductor. It's blanked and then it's punched, and that's where you develop the parts of it. And we'll look at this in a little more detail in just a second. Here's the actual molding of the squirrel cage rotor, and we'll look at let's see, where do we have? Yeah, it's coming up. Hold on, we got a really great picture here in just a second. But anyway, let me just, since we're talking about that, I'm going to jump ahead. Here is that squirrel cage, with these bars, and they're all connected to this cast aluminum. So you short circuit this bar. That's what he's talking about. And then inside of that, you stack these laminated plates around this squirrel cage. Okay, so that's how this thing is formed, and you know, so you know, it actually is a squirrel cage looking thing, and then we add these plates in there, and all of that has to do with the magnetic properties of the motor, and makes it function better, increases the efficiency, and so forth and so on. So anyway, that's what do we got? Is there anything else we need to talk about? Not really. You know, this part here is talking about how you would, you know, you actually shape and form this, you know, with aluminum that is molded, compressed and molded into these forms that we use. And then the other type of motor is this wound rotor induction motor. And it is built a little bit differently in that you actually have windings on this thing. And there's actually also these slip rings, basically, that are incorporated into the motor. But for right now, we just want to name them. We got to, you know, we name them. We talked a brief minute about how they're formed. And then the next thing we'll do is we'll go into the principle of the operation of this thing.